The simple probability of flipping a coin and getting heads is 1/2. But remember, if we flip a coin more than once, this is called compound probability. And what we do is we just multiply each time. We flip a coin once, it's a 1/2. We flip it again, it's another 1/2. So say if I wanted to spin a spinner that had 4 parts to it, and one had red, one had blue, one had green, and one had yellow, and I wanted to see what the probability of it rolling, flipping the coin 6 times and getting all heads, and then spinning it and getting a green, we would have to take this value and multiply it times 1/4, since there are 4 different colors of the spinner and 1 is the color we want. We just keep multiplying and find out the probabilities. So you multiply across, all those are 1, so 1 times 1 times 1 times 1 times 1 times 1 is 1, and 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, and 64 times 4 is 256. So this would be 1 over 256. Again, on compound, you just multiply them. Now, we also learned that we dealt with things that are independent events, events that do not affect the other. So in this situation, we have 2 different color cubes, one red, one blue. If you roll the red one, that does not affect what the outcome is going to be for the blue one. So these are called independent events. So when we find them, we find the probability of the odd, that the red is going to be odd, is 1/2, because there are 3 odds out of 6. The probability that the blue one's going to be odd is the same, 3 out of 6, 1/2. So when we have them, they do not affect each other, so that's still 1/2. No matter what this is going to be, the probability of the blue one will still be 1/2. So the probability of the red and blue both being odd is going to be 1/2 times 1/2, which is 1 over 4. Means there's a 1 in 4 chance that when we roll both of these die, these red cubes and the blue cube, then it's going to be one time they'll both be odd. And the last thing we talked about is probability of dependent events. So normally we have 52 cards in a standard deck. And the trick on this problem is that it says without replacement. In other words, you're going to pick this 4 of hearts, which there are only 1 4 of hearts in the entire 52 deck. But once you don't replace it, there are no longer 52 cards in that deck. Now there are 51. And so now we have a 10. There's only 1 10 of diamonds. And now we have to multiply. 1 times 1 is 1. 52 times 51 takes nice calculations, but I've already done it for you. 2,652.